continue to look at shells and go a little bit more in depth. So we're starting out here with a diagonal line, slope of 2, y-intercept of -4, and then we're dealing with a parabola, which we are then revolving that about the x-axis. So if we graph that, we have our parabola, we have our diagonal line, and then we have our axis of revolution down here being the x-axis. Well, if you have a horizontal axis of revolution, we know then that we're going to be dealing with y's. So each one of these functions up here, we need to solve for x so we can have stuff in terms of y. Now, notice your parabola right here. The right side factors into an x minus 2 and an x minus 2, so it's an x minus 2 all squared. So then to finish solving it for x, you could take the square root of both sides, and then you could go ahead and add 2. Now, when you're looking at this one here, to solve that, you could add 4 to both sides, and we get this, and then divide both sides by 2. So we know we're dealing with y's. So our bounds have to go how far up and down? Well, we touch at 4 up here and touch down here at 0, so that tells us our bounds of 0 to 4. Remember, with shells, it's a 2 pi in front, not a pi. Pi is for washers and discs. Shells has a 2 pi in front. Then the first thing here is your radius. Your radius is always perpendicular to your axis of revolution, and then is either your variable minus your axis of revolution or the other way around, depending upon which one's bigger. In this case, it's our variable right here of y minus our axis of revolution of 0, because it's always big minus small. And then when we look at our height of our shell, that's got to be perpendicular to your axis of revolution. So you have to go what's on the right minus what's on the left. Well, the right is our parabola, which is this right here, minus what's on the left. Well, that's our line, which is this right here. Well, we can go ahead and distribute through here, and in that case, our 2's would drop, and we'd be left with our root x and our minus 1/2 y. Still with our y in front, so we could distribute through that y into the parentheses, and now it would be pretty easy to integrate. So we'll leave the 2 pi in front, integrate each one of these y's, then we have to evaluate it from 4 to 0. Plug in 4 minus what you get when you plug in 0. Once again, I'd probably just type all this into my calculator at once, then multiply it by 2, and then know that my answer is going to have a pi hanging out in it. This one here, when we graph it, we have our cubic function here, we have our x-axis here, we have x is equal to 1 here. So we get this shaded region here. We're revolving around the x-axis again, so therefore we have to be dealing with our y's. So we put our 2 pi down, our y's, our bounds, because we're dealing with y's, is how far up and down our shaded region goes. Starts at a height of 0, goes up to a height of 1. Well, we need to have this where an x equals. So to solve that for x, because we want to be able to plug stuff in that has y's, we need our formula with a y in it. We could cube both sides. So now all we have to do is look at our radius. Your radius goes perpendicular to your axis of revolution into the shaded region, down to your axis of revolution. It's your variable then of y minus your axis of revolution of x. Then your height of your shell is perpendicular to that, so it goes what's on the right, which is our line of 1, minus what's on the left, which is our curve, so it's going to be 1 minus our curve of an x cubed. Well, all we have to do now is simplify this a little bit. We could distribute through. Now it's in a form that's easy to integrate. Plug in our 4 minus what you get when you plug in 0, and we get 3 pi over 5. Looking here, we graph our x is equal to 2. That's a vertical line at x being 2. Y is equal to 2. That's a horizontal line at a height of 2. And then we have x is equal to this, which is a horizontal, or not a horizontal, but a parabola. If you would square both sides, you'll notice you get an x squared is equal to y plus or minus 2. Then you could add 2 to both sides. So you can see where it ends up being a nice normal parabola. So that's what we have here. We're looking for the region that's bound by all three of those. And that's this kind of not quite triangular shaped region. Our axis of revolution is the y-axis. So it's a vertical axis of revolution. If it's a vertical axis of revolution, we know we're dealing with x's. So your bounds have to be how far left and right, because x goes left and right, that your shaded region goes. It starts at 0, goes all the way over here to 2. Well, then your radius, which is the red, goes from your shaded region to your axis of revolution. So it's your variable, which we're dealing with x's, so it's going to be x minus 0. It's the right minus the left. Then your height of your shell is perpendicular to that, so it's got to go top minus bottom. When we're looking at top over here, that's your parabola, minus what's on the bottom, which is your horizontal line of 2. So in this case, the 2's drop. So we'd have an x times an x squared, which is your x cubed, and that's easy to integrate. Then it's easy to evaluate. Remember to plug this in, times it by the 2, and in this case we get 8 pi. Here we have vertical line of x is equal to 1. We have x is equal to y cubed. So if you wanted to graph that using your calculator, you could take the cube root of both sides and you get y is equal to the cube root of x. That might help you graph it easier. And then you get y is equal to 0, which is your x-axis. And we're revolving around the y-axis. Well, vertical axis of revolution, we know we're dealing with x's. So we graph all this. We have our x is equal to 1, we have our y is equal to 0, and we have our curve, so that's this shaded region right here. That's what we're revolving around our y-axis. Since we're dealing with x's, our bounds are how far left and right we go. It goes from 0 to 1, so that's our bounds. Then it's your variable minus your axis of revolution, because your axis of revolution is on the left, so it'd be x minus 0 or x. Your height is perpendicular, so it's got to be the top of your curve minus the bottom of 0, so it's really just your curve minus 0 or your curve. So this is really an x times an x to the 1/3, so we get an x to the 4/3. Well, now that's pretty easy to integrate, so we integrate that. Throw in 1 minus what you get when you plug in 0, and you get 6 pi over 7.